Okay, very good afternoon, everyone. Today's topic of discussion is Warshalls algorithm. Now, coming to dynamic programming, in the last class I had explained about multi-stage graphs. Today we shall continue with Warshalls algorithm. Now, this is all pair shortest path problem. There are two types of problems in this all pair shortest path problem. They are Warshalls algorithm and Floyd's algorithm respectively. Before solving, before knowing how to solve Floyd's algorithm, we should know what is Warshalls algorithm and how to apply algorithm and find out the transitive closure or how to solve the particular problem on Warshalls algorithm. Let us see. Now here you need to remember three things. You need to remember three things. Digraph, adjacency matrix, and transitive closure. Now you may be knowing what is digraph. Digraph is nothing but it is a directed graph. Digraph is nothing but it is a directed graph. Digraph is a directed graph. Now there is a direction from A to B. There is a directed edge from B to D. There is a directed edge from D to C. Now, if we are writing an adjacency matrix for this graph, how do we write? A, B, C, D. There are 4 rows and 4 columns. Depending upon the number of vertices that are present, we are going to write that many number of rows and that many number of columns. Since there are 4 vertices here, I am going to write 4 rows and 4 columns. Now you can see how do I write that adjacency matrix for the graph. What is an adjacency matrix for the graph? Adjacency matrix for the graph is nothing but if there is a direct edge from one node to another node or from one vertex to another vertex, then we put a value 1 to that, that ith row and jth column. Now supposing if there is a direct edge from vertex I to vertex j, then matrix at ij, matrix value at ij is 1. If there is no direct edge from A to B, now here there is no direct edge from A to D. So the matrix value would be 0. In this way, we are going to fill our matrix with Boolean values, either 0 or 1. Such kind of matrix is called as adjacency matrix. Am I clear with this concept?
Yes, sir.
Yes,
Okay.
sir.
Now you can see A to B, A to B, A to A, there is no edge, so it is 0. A to B, there is an edge, so it is 1. A to C, there is no edge, it is 0. A to D, there is no edge, it is 0. B to A, there is no edge, it is 0. B to B, there is no edge, it is 0. B to C, there is no direct edge from B to C, hence the value is 0. There is a direct edge from B to D, the value is 1. You can see there is a direct edge from D to A, hence the value is 1. There is a direct edge from D to C, hence the value is 1. This is an adjacency matrix. Okay, we have understood the concept of digraph. We have understood the concept of adjacency matrix. The next concept that needs to be understood is transitive closure. The next concept that we need to understand is transitive closure. Okay. What is a transitive closure? Transitive closure is a Boolean matrix which consists of Boolean values within it, where the presence of Boolean value 1 indicates that there is an edge of positive length from vertex I to vertex j. Now, if there is a direct edge from vertex I to vertex j, then the value would be 1, else the value would be 0. Now, supposing you can observe here, if I'm going to write the transitive closure of this graph, A to B, there is a direct edge, so no problem, 1 I have written. A to C, yes, of course, there is an edge of positive length. A to B, there is a direction. B to D, there is a direction. And from D to C, there is a direction. So, if we sum of these values, we get the distance from A to C. So, A to C, if I have to travel from A to C, I have to go through B. then I have to go through D, then ultimately I have to reach C. So that is what I have written here. A to A to B I will go, B to D I will go, D to A I will come back. So it is 1. Next A to B is 1. A to C, A to B, B to D, D to C, which is 1. Next, what is A to D? A to B, B to D, which is 1. So, based on this positive edge, positive length edge from A to some vertex to another vertex, we are going to fill either with 1 or 0. Now, if we take up this Cth row and 8th column, C to A, there is no direction. So it is 0. Again, C to B also, there is no positive length of path. It is 0. C to C also 0. C to D also, it is 0. Again, if you see D to A, D to A, D to A, there is a path, hence it is 1. D to B, there is a path through A, D to A to B. Then D to C, D to A to B, B to D, D to C, or D to C, there is a path. Next, D to D, there is a path. D to A to B, B to D. There is a path, hence it is 1. Am I clear with this concept of transitive closure? Am I clear?
Yes, sir.
Okay. Right. Who is Vivek Maurya?
He is one of my friends, sir.
Okay, right. Okay. We shall go with how to know the aim of this. Now, after understanding the concept of digraph, adjacency matrix, transitive closure, you should know what is the significance of Warshalls algorithm. Now, Warshalls algorithm is going to find a transitive closure of a particular directed graph. Given any directed graph or digraph, if we have to find a transitive closure for that graph, that means given this graph, I need to get this matrix. What is that process called? That process is called as Warshalls algorithm process. We are going to apply Warshalls algorithm and we are going to get a transitive closure. This is a transitive closure for this digraph. Now here we have taken a simple example. This is a digraph. So in the first step, what we do is R superscript 0. Now R superscript 0. I hope you guys can see, right? Okay, we shall.
Can you zoom, sir?
Surely. Can you see now? Can you see?
Yes, sir.
Okay. Okay. In the first step, what I'll do, this is R superscript 0, R power 0, or R power 0 within brackets. In the first step, what I will do, I'll just write down the adjacency matrix for this graph. What is an adjacency matrix? I have told you previously, it is nothing but if there is a direct edge from one vertex to another vertex, then that value would be 1 correspondingly in the matrix. That Boolean value would be 1. If there is no direct edge from one vertex to another vertex, then that value would be 0. So in the first step, what I will do is,
Sir, unable to hear you, sir.
okay. In the first step, what I will do is, I will just write down the adjacency matrix and I'll mark the first column and first row. Am I clear with this step?
Yes, sir.
I'll write down the adjacency matrix, I'll mark the first row and I'll mark the first column. Now, if I have to find out R1, if I have to find out this matrix, I have to keep this matrix in my mind. So I'll keep this matrix in the mind, and what I will do is, now I have to change these values. Whatever is there within the box, don't look into those values. Whatever values are there outside the boxes, only such values needs to be changed. Of course, if there is 1, then don't need to change. If there is 0, then we need to change it to 1. There is certain criteria for that whenever we are changing 0 to 1. Am I clear? Am I clear? Okay.
No, sir.
Not cleared?
No, sir. Again, sir.
Okay. Now supposing what in the first step I'm going to write the adjacency matrix. What is an adjacency matrix? This matrix we are going to write. Given this graph, we are going to write this matrix in the first step. In the first step, okay? Next, what I will do, I'll mark first row and I'll mark first column. Am I clear with this?
Okay, sir.
Then what I will do, whatever values are there within the boxes, such values needs to be preserved as it is. Rest of the values I'm going to change. That means values that are present outside the box, such values needs to be changed. Now, how will I change it? How will I change it? Now, I have to keep this matrix. After doing this step, I'll keep this matrix and I'll find R1. How do I find R1? If I'm going to find R1, A to B. Now, first I have to take the vertex in the order. First vertex that I take is A. Now I have to find a path between two vertices such that there exists an intermediary vertex A. A can come before B or after B. A can come before D or after D, anywhere it can come. Now, which is such a value here? If you take here, this is also remains same. Now, if you take this B to B, B to B, B to B, B, D, A, B. Of course, D is coming there, so we are not supposed to take that path. In the second step, in the first step, no, keeping this matrix in mind, we should make sure that there is an intermediary vertex which is only A. I'll start from A, okay, one by one, A, B, C, D, like that. I'll take in order. In the first step, what I'll do, I'll take only vertex A. I'll take only vertex A, and I'm going to use that vertex A as intermediary vertex, and I'm going to find the shortest path. Once I find the shortest path, corresponding matrix value will be made 1. Whichever matrix value is 1, you keep it as it is. Don't change such value. Now, supposing you can see here, looking at this first step, I have changed this value. Whatever values are there in the dark manner, such values are changed. 0 is made 1. How? You may question, sir, you told 0 is made to 1. How is it possible? How have you done? You may wonder. This is where the trick is. D to B. If you check a path from D to B, D, A, B. D to B. A is coming in between, right? Am I clear with this step?
Yes, sir.
A is coming in between. Okay. Now I'll check for this. 1 is already present. D to D we shall check. D to D. D. A. B. D. B is coming here. Okay. B is coming here. D, A, B, D. A, B are coming. So I am not supposed to take A, B. I should take vertex of length only 1. That means intermediary vertex should be only 1 vertex. That is A only. I cannot take 2 intermediary vertices A and B. Of course, in the next step, I have to take B. Maximum now I can take is only 1 intermediary vertex in between. So now here I have filled 1 by looking at this matrix. D to B, D, A, B. Only 1 intermediary vertex, which is A, 1. So I fill 1 here. Now I'll keep this matrix in my mind and I will derive this matrix. How do I do it is the question. Now if you see here, whatever values that I have marked within the box, don't change those values. You change and you concentrate only on such values which are outside the boxes. So here, if you take A to D, now for deriving this matrix, I should take intermediary vertex length not greater than 2. Maximum should be 2. And which are those vertices that I can take? In the previous step, I have taken A. Now I should take AB. I cannot take C. Am I clear with this? Am I clear with this? I'm clear. Am I clear? Are you guys able to hear me?
Yes, sir. It's clear, sir.
Okay. Right. Now AB. We shall look into this matrix and we'll find this. Okay. We have. Let us see A to D. This is the new value. 1. I'm going to change. Now initially it was 0 in the previous step. Now it has become 1. How, you may ask? Sir, how did it become 1? You see A to D. You see, measure the path here. A, B, D. A and B are intermediary vertices, right? They are existing, right? So we will make it 1. Now you take a path from D to D. If you take a path from D to D, D, A, B, D. D and D are on the extreme side, on the left side, and on the 1D on the left side, 1D on the right side, and A, B are in between. A, B are in between. So ultimately I got this matrix. Now I'll keep this matrix in my mind and I'm going to find this matrix. I will keep this matrix in my mind and I'm going to find this matrix. If you see, now which are the vertices that I need to take? You guys tell me. Which are the vertices that I need to take? Debo Jyoti?
D, sir.
How D? See, in the first step for deriving this matrix, I have taken A as the intermediary vertex. Next, I took A, B, 2 vertices. Now I have to take A, B, C.
A, B, C.
Okay, I have to keep this matrix in my mind and I have to derive this matrix. How do I derive that matrix? By keeping A, B, C as intermediary vertices in my mind. I have come in order. In the first step, I kept this matrix and I took A as intermediary vertex and I got this one.
Sir,
Yes.
in second step, which
Yes.
one have to take as intermediary matrix?
In this one or this one? This one? You're asking about this
No,
matrix.
sir.
This
Upper
matrix.
one. Yes, sir. Yes, sir.
This is adjacency matrix. You keep it as whatever you got adjacency matrix, you keep it as it is. From this vertex,
Okay,
I need to derive this matrix. To derive the second matrix, I need to take intermediary vertex as A, only A. Understood?
okay, okay, sir.
In the
Yes, sir.
initial step, the length should be only 1. Maximum length should be 1. Only I can take A. Now for deriving this matrix, from this, I need to take AB. That means maximum vertex length is AB, 2. It should not exceed more than 2. AB or 2, right? It should not exceed more than 2. Now if I have to derive this, I need to take ABC. Now I have taken this. I need to change this, this. Now can we change? You just see. A to A, B, D, A. C is not coming in between, right?
Yes, sir.
So what I'll do?
0.
I'll keep it. I'll not change it. Now if you take C, through C, no vertex is being reached. C out degree is 0. Out degree of C is 0. So I'll leave it as it is. Okay. Now that is what they have given. A, B, C. If I take A, B, C, A to A, can you measure? A, B, D, A. C is not coming in between. So I can't change it. I'll keep it 0 only. 1 is already there. I can't do anything. Leave it. Now I can't touch this value also because it is inside box. 1 is already present. If I want to change this 0, B to A, you check. B, D.
Sir, in this step, C will never come, sir.
C will never come. So I will not change the value if C is not coming. Okay. C is not coming, right?
Because this is a not circle, sir.
Yes. So I will not change the value. I'll keep the matrix value as it is. Wherever 0 is there, I'll keep 0 as it is. Am I clear with this? Am I clear?
Yes, sir.
Okay. Now keeping this matrix in my mind, I need to find this matrix. Remember, when will you know that you have found out the transitive closure of a graph? Whenever I get R4, how many vertices are there? A, B, C, D. There are 4 vertices. So that many that many number of matrices I need to solve. Once I get 4 matrices, because there are 4 vertices here, I am going to get 4 matrices. Once I get 4th matrix, I'm going to stop and I'm going to conclude that as a transitive closure. Okay, that we have understood. Now, keeping this matrix in my mind, I need to find transitive closure for the next matrix, which is a transitive closure. Now, how do I find it? I'll take 4th row and 4th column. I'll forget this. I'll not look into these values. Now I need to change only these values. You can see A to A. What is the path? Now remember, when I'm taking this matrix and arriving at this matrix, what is the set of vertices I need to take? I should take A, B, C, D. For this I have taken A, for this I have taken AB, for this I have taken ABC. Now I need to take A, B, C, D. Now if I am checking from A to A, B, D, A, B, D, A. Remember, the length should be in such a way that it can exclude some of the vertices. Maximum it can include only 4 intermediary vertices. It should not include more than 4. If you see A, B, D, A. Now if I'm going to see from A, 1 is already there, I'm not going to change this. A to C I will check. A, B, D, C. It is covering all 4 vertices. Again it is 1. This is already 1. I'm not going to change it. I'm going to leave it as it is. Now I have to check this. B to A you check. B, D, A. So it is, okay, B to A is 1. B to B if I check. B, D, A, B. It is 1. B to C if I check. B, D, C. It is 1. Now ultimately 4 matrices I have got. There are 4 vertices, so I should have got 4. I should have got within 4 steps only. So ultimately I will return the value of this matrix completely. Now this is the transitive closure for a given digraph. Am I clear with this step? Any confusions? Any
No,
confusions?
sir.
Yes. Any confusions?
No confusion, sir. Yeah.
Okay. Okay, now the thing is, if you have understood this, this is one way of solving this
Sir,
Warshalls algorithm. Yes. Yes.
sir, in last step, it's not covering all the vertices, no?
See, it is not a
Maximum it
compulsion.
should cover 4.
Maximum it should cover 4. It can cover less than 4 also. Here, why we are not taking
Yes.
for C is, now I understand your confusion. You're asking C, here we have not taken C. If you check out these values, from C to A, there is no, from C to A or C to B or C to C, there is no any edge. So in such cases, I'll make it
Out
0.
degree is 0, no, sir.
0. So I'll keep it as 0 only. I'll keep it as 0 only. Out
Okay,
degree is 0 for C, so I'll keep it as 0 only. Any vertex from C, it is 0. Whether C to A or C to B or C to D or C to C, it is 0. Now remember, this is the rule. The rule says that if you are traversing from one vertex to another vertex, if you have taken A, B, C, D as the intermediary vertices, it is not a compulsion that you should get always A, B, C, D as intermediary vertices. It should be maximum 4 or less than 4. In this vertex, maximum A I can take. So for getting this matrix, I can take maximum intermediary vertex as A. For this, A, B, maximum 2 only, A, B, or less than A, B, that is A, or only B. In this, I have to take A, B, C, or less than A, B, C. That means A, B, C's number is 3. I can take 2 intermediary vertices. I can take 1 intermediary vertices. Here in this matrix, it is A, B, C, D. I can take only A, B, C, D, or A, B, C, or B, C, or only A. Now, this is, trial and error method. If you are applying the actual dynamic programming technique, in case of dynamic programming technique, what we are going to do is, we are going to overlap the solutions. What is overlapping the solutions? Whatever solution we have got in the previous step, that solution we'll use it as a clue for next step. If you see this algorithm here, now tracing this algorithm is very huge. Tracing this algorithm is very huge. If you see this algorithm, first I'll ensure now K is a counter for number of vertices in a graph. N is a counter for number of vertices. K is for number of matrices, number of iterations that I am going to carry. And I is for number of rows. J is for number of columns. J is for number of columns. If you look into this formula, RKIJ, now there is already R. R0 is already there. Next I have to find out R1. So how will I apply the formula? R1, I value is 1 in the first iteration. R1 of 1 comma 1 is equal to K minus 1 means 1 minus 1, which is 0. R0 of 1 comma 1 or R0 of 1 comma K value is 1 comma 1 and R0 of 1 comma 1. It is very simple. It is just like Boolean operation. First, what you're going to do, you're going to solve this within the brackets. You're going to solve this within the brackets. What is R0 of I comma K? I value is 1, K value is 1. R0 of 1 comma 1. What is R0 of 1 comma 1? If you see in this matrix, R0 of 1 comma 1. First row, first column, it is 0. 0. Okay. 0. And remember, and means it is multiplication, Boolean multiplication. Now you would have studied in ADE. 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 1. Again I'm going to take, now this is 0, this value is 0. Remember, R0 of K value is 1, J value is 1, R0, 1, 1. R0, 1, 1. First row, so R0, 1, 1. First row, first column. Again it is 0. What is 0 into 0? 0 into 0, Boolean value is 0. Then I'm going to OR it with this expression, that is R0, 1, 1. Again R0, 1, 1 is 0. 0 or 0 is 0. So that is what I have done. If you see, R1 of 1, 1 is 0. I have placed it as it is. Like this, I'm going to overlap the solutions and I'm going to find out for all the, now if I use this procedure as it is in algorithm, it is a huge procedure. It takes pages of time. So if I am solving it by this technique, it would be really easy. Am I clear with this? Am I clear with this?
Yes, sir.
Now, okay, this is the end of Warshalls algorithm. We shall see the next set of algorithms in